In this video, we're going to explore the results in at risk. Recently, we completed the simulation that you're looking at right now. And so what I would like you to see are different ways that we can manipulate this output. This is the basic output, it's total cost. If you look over here on the right, you will see a numerical summary. The smallest budget that we might need would be about $549. This project could cost as much as $2,150. The mean would be $1,238. That's quite different than the $990 we obtained from our point estimates. So it looks almost certain that I'm going to have an overrun that I'll be responsible for. If you scroll on down, you'll be able to see here that we have a number of values. The left X, this refers to the left delimiter. So the left delimiter is on 826, and that's what you see right here. The left P is the probability that you would get a value of 826 or less. The right X is $1,710. The right P is 95%, and then you get the differences. If you continue to scroll down, you'll get percentile values. 1% of all the 1,000 iterations that we did were equal to $703.51. If I scroll down randomly and just grab the 60th percentile, 600 of those numbers were $1,285.87 or less. So you have numerical data available here. I'm concerned with cost in excess of $1,100. So I have a couple of options here. I can grab this scroll bar, or excuse me, the delimiter, and move it on down to $1,100. And notice now I see there's a 65.1% chance that this crab cake luncheon will cost me more than $1,100. I'm glad I did risk assessment and found out that I could be in trouble here. So there's a 2/3 chance that I'm going to have to pay something out of pocket, and I didn't know that with my point estimate. Not only that, but if I look at the maximum over here, $2,150, that tells me my exposure, the maximum loss that I could be looking at here is $1,050. This could overrun my budget by $1,050. Thank goodness for risk assessment. Let's see what else we can do. If I do a right mouse click, I see graph options comes up. And if I select graph options, we're going to see more options than we're going to look at right now. All I want you to know is that this exists. There are a number of tabs here. You can change the look of the distribution. That we will do. We'll change it from the probability density function that we're looking at to a cumulative ascending curve. And you see that takes the very same data and graphs it quite differently, dramatically different. We'll learn about this as we go through the program. Right now, we're just learning how to work the software. There's a title tab, and you can go in and type a title here. Quite literally. You can go into the x-axis and change the display, change the scaling, change the formatting. You can do the same on the y-axis. You can change the way the curves look, the colors of the curves. You can add or subtract legends. You can alter the number of delimiters. And there are many other things that you can do. Let me cancel out of that right now. And let me also close this. Now if we go up to our results and I click right here, Simulation Detailed Statistics. When this number comes up, notice that I have data on the total cost, that's an output. I have data on the number of people, that was that Poisson distribution. And I have data on the cost per person. And running down the rows you can see the minimums, maximum, mean, and if we scroll on down we can see that we've got percentiles as well. A nice feature down here is if you had a particular value that was important to you, like $1,100 is important to me. I type that in. And now this is telling me that's the 34.9% percentile. In other words, 34.9% of all the values in our simulation output were $1,100 or less. If I wanted the 97.5 percentile, now I'm typing in the, whoops, excuse me, my mistake. I need to look at what I'm doing. 97.5 percentile. I see the value above. That is 1779. So 97.5% of all the numbers generated by this model were $1,779 or less. You can query the inputs in the same fashion. So you get detailed statistics. You also get your data. This gives me a list of the 1,000 results that we got. In the first iteration of the model, there were 43 people and crab cakes were $22.22 a piece, and the overall cost was $9.55. This can be very nice because you can export this table into other software and prepare display graphics and that sort of thing. I'm going to stop there. There's much more that we'll learn, but we're just getting started, and that's enough for this video.